Okay, welcome to AP Calculus. This is our second day that we'll be working with related, or our second lesson, but second day on section 6 from chapter 5 for related rate problems. And boy, they start out right with one. You'd think that, we've got a number of example problems in here, and you think they'd ease us in, but I believe this example one is one of the toughest problems in the section, and it is, in my opinion, the toughest problem in the handout of this lesson. So let's get started. We're going to have our calculators ready to go with us, and we're just going to hopefully get some wisdom along the way here. Water is flowing at the rate of 50 meters cubed. So I've already got a rate from a concrete conical reservoir vertex down. So I'm not worried about proportions right now. Basically, this thing looks like this, of base radius 45. So the base is, even though it's the top, still the circle. So this guy is 45 with a height of 6. So what I'm going to do is I'm just going to separate that. And you can see I'm not drawing this square to scale. This is definitely not scale. A lot of times we're just interested in that cross section right there. And I'm going to just refer to this, of course, as height, and this, of course, as radius. So let's continue reading. How fast is the water level falling? So the water level, obviously, I guess it starts at 6 and it starts draining down. So this is draining down. At some point, I'm interested in what's happening when the water's 5 meters deep. So maybe I'll just put that here. So at this point, we got kind of our water level right here. I'm interested in when this is 5. When this is 5, this length, this radius is changing as well as it's coming down here. So maybe I need to know how R and H are related. When my height is 5, what's my radius? So I'm going to go ahead and just set this up. I've got R is to 45 as H is to 6, or 6R is 45 times H, or R is divide 6, reduce 3, 15 halves H. And if I've got that equation, I've also got this one. H is 2/15 R. And what will that give me? That'll give me the ability to turn R's into H's or H's into R's as need be. I'm probably going to, since they basically are giving me a volume, I'm probably going to be finding a dV dt, so I probably want to talk about the volume as well. So volume of our cone is, and this is based on where the water is, not the entire cone. Volume formula for a cone is 1/3 pi r squared times h. Now, I realize if I take the derivative of this, I'm going to get a dV dt, which is wonderful. That's a 50. I'm going to get a dr dt along the way. Dr dt, great. I'm probably going to want that somewhere. Dh dt, great, but I don't want to have too many variables. Let's see what we're looking for. How fast is the water level falling? The water level is my h. So I want to have a dh dt. That is dh dt right there. They are asking what is dh dt. That's like question number 1. Then how fast is the radius of the water surface changing at that moment? Well, question number 2 is what is dr dt? Those are the 2 questions. And then as if it wasn't enough for us to do, they're giving us our values in meters, and they're asking us, oh yeah, by the way, convert to centimeters in units. So we're going to have to be really, really alert to that. Man, if I was taking this on an AP test, I would maybe have arrows all over to remind myself, when you get down the road on this, we're going to change things to centimeters. Okay, so since they asked for dH dt first, I love having an H in here. I wish I didn't have R's. So since R is 15 halves H, R can be replaced by 15 halves H, and I would get still volume equals 1/3 pi times 15 halves H squared times H. And let's clean that up a little bit. I get volume equals, let's see, 15 squared, 225 times 1, 225, 2 squared, 4 times 3, 12, pi H cubed. I'm recording right now, if you don't mind. Thanks. Okay, so at that point, I'm going to go ahead and take a look at the derivative. I get dv dt is 3 times, well, I guess I'm just going to write it out. I'm not going to take additional steps first time looking through simplify here. I get 225 on 12 pi times 3h squared but dh dt. So there's our derivative. I'm going to not do any substituting yet. dv dt is 3 reduces the 12 to 4. So I get 225 on 4 pi h squared dh dt. And now let's put in things that we know. Well, dv dt is basically given. dv dt is the volume is changing at a rate of 50, and you could put in negative 50 here, but we always have to interpret whether we should have positive or negative answers based on the question. So I'm going to go 50 equals 225 4 times pi. We're interested in what's happening when the water is 5 meters deep, so times 5 squared dh dt, and we're at this point. So at that place right there, I'm going to go to calculator right here. I'm going to clear that out. I'm going to make it so we can see it maybe just a little bit better. Is it too bright? Let's take a look. I'm going to start with 50. To get rid of the 4, I need to multiply 4. I'm trying to get everything away from dh dt. I need to divide the 225. I need to divide this 5 squared, or 25. I'm not going to divide pi. I don't want a decimal answer. I'll just include that in my answer in just a moment here. And I get math fraction. I'd rather not have a rounded answer. 8 on 225. So I get dh dt equals 8 on 225, but also on pi. So we're dealing with exact answers now. Now, that is dh dt, but that would be in units meters per minute. And we're supposed to go centimeters. So if I convert this to centimeters, I get dh dt equals 800, not 8,000, 800 on 225 pi. And sure, we could do that in our head, but let's go 800 divided by 225. We could reduce this guy. Math fraction, love math fraction. That's probably why they put it first. 32/9. So dh dt is 32/9 pi. Now, really important that we answer this correctly. If it said, how is height changing? Our height is changing at a rate of negative. That's what would have happened if we had the negative in for the 50. But we can't just rely on that. We have to read the question. How fast is the water level falling? So that's taking the negative into account. The water level is falling at a rate of 32 on 9 pi meters per second. Okay, that is one of the questions asked. So I've got this guy, dr dt now. How fast is the radius changing? Well, if I'm trying to find dr dt, I want an equation with r in it. I've got an equation with r in it right here. I'd like to have an equation solved for r. I could solve this for r. But let's not discount, hey, I've got an equation with r in it right there. Or solve for r right here. Why don't I work with r equals 15/2 h? If I'm looking for dr dt and I take the derivative of both sides, I'm going to get a dh dt over here. Is that a bad thing? It's not a bad thing when I know dh dt. It's going to be way easier than going through the whole volume formula again. Therefore, I've got dr dt is 15/2 dh dt, or dr dt equals 15/2 times, there it is, 32/9 pi. And maybe I'm being lazy here on calculations, but I'm going to be careful with this. So what do we get? I've got 15 times 32 divided by 2 divided by 9. Don't forget we're still dividing by pi. Math, fraction. I get 80/3 with a pi in the denominator. I didn't include it yet. So dr dt is that. Let's answer the question. How fast is the radius changing? Okay, now they said the water level falling. They didn't say the radius decreasing. They said the radius changing. So is the radius getting bigger or smaller as the water drains? Well, clearly the radius is getting smaller. So had we included the -50, we'd have the negative here and need to exclude it. We'd have the negative here and need to include it. So we have to be really careful in answering our questions. I mean, this problem has tons of pitfalls in it. So the water level, now you could probably get away with saying is falling, or excuse me, it's not the water level. The radius of the surface, you could probably get away with saying is decreasing at a rate of 80/3 pi meters per centimeters, or excuse me, this was centimeters, by the way. We changed it to centimeters per second. I bet you knew that. But since they said changing is changing at a rate of -80/3 pi centimeters per second. So, man, there's a lot of little traps in this problem. Hope that was okay for you. If not, worth watching again. Probably the best thing you could do is kind of come back to this problem and try it again from scratch, maybe an hour from now. Who's going to take me up on that? All right, let's take a look at example number 2. This is a really, really common type problem. So is the one before, but again, there was a couple of little pitfalls put in there within the directions, things that could be put in there to trip us up. We've got this dinghy, this little boat is pulled toward a dock by a rope. Now, I wouldn't be surprised if you see this problem again sometime and the diagram is not drawn. From the bow through a ring on the dock 6 feet above. So this 6 is going to be constant. The boat's sliding in here. I'm going to call this X. I'm going to call this R, either for rope or radius that we're spinning around here, as I see they're talking about theta. Wouldn't surprise me later on if they ask for us to find how the angle measure is changing. Okay, so 6 feet above. The rope is hauled in at a rate of 2 feet per second. So as I like to say, talk calculus to me. 2 feet per second, the rope is being hauled in, so the rope is shrinking. So dr dt is -2. Okay, now there's lots of formulas we could put in for this. I could get r squared equals square root of 6 squared plus x squared, or x squared equals square root of, or excuse me, just r equals square root of 6 squared plus x squared, or x equals square root of r squared minus 6 squared. I could talk about trig functions with theta and the ratios between r and x and 6, etc. So let's take a look what they're asking for here. How fast is the boat approaching the dock? How fast is the boat approaching the dock? Talk calculus to me. Find dx dt. How fast is the boat approaching the dock? When the rope is out 10 feet. Well, when the rope is out 10 feet, this is 10, this is 6, this is 8. But I need an equation with x in it, so here we go, because I want dx dt. If I got dx dt, I want an equation with x. I'd love more than anything else, to have an equation that just said x equals. So I'm going to go x equals square root of r squared plus 36. So dx dt equals 1/2 r squared plus 36 to the -1/2 times 2r dr dt. And that simplifies. The 2's cancel. I get r dr dt on the square root of r squared plus 36. That's dx dt. Well, what do I know? Well, now I know at some instant, now this was a variable, 8 was a variable, 6 was a constant, but at the instant I'm interested in, r is 10. So dx dt is 10. dr dt is fixed at -2, remember? On square root 10 squared plus 36, so I get -80 on 100. Oh, this is minus. I'll bet you saw that too. All the way back to here, minus. Sorry about that, minus. So 100 minus 36, 64. Square root of 64, 8. I got ahead of myself there. -20 on 8, or -5/2. Now, does negative make sense for this? It says, how fast is the boat approaching the dock? Well, since they put approaching the dock in, the negative doesn't make sense. We're not dealing with left, right. They've already counted that the rope's getting smaller. If they asked, how is the distance changing from the boat to the dock? So we would say the boat is approaching the dock at a rate of 5/2 feet per second. Okay, and sure enough, at what rate is angle theta changing at the moment? So I want to talk about angle theta. I could talk about angle theta with sine, x on r. I could talk about theta with tangent, x on 6. I could talk about theta with cosine, 6 on r. At what rate is theta changing at that moment? At what moment? At the moment that the rope is 10 feet out. So this is 10. I probably would use x on 6, maybe tangent. I think we got some viable options here. So I'm going to say tangent of theta is x on 6. See, I know what dx dt is now. I know dr dt. I think that we could have just as easily gone with cosine. I'm going to go tangent, let's go, I could take tangent inverse of both sides and just get theta alone, but I don't want to work with tangent inverse derivative. So I'm going to take the derivative right now. That is secant squared theta, d theta dt, that's what I'm looking for. How fast is theta changing? Equals 1/6 dx dt, or d theta dt equals dx dt on 6, either divided by secant squared down with the 6, or maybe just times cosine squared of theta. All right, what do I know? dx dt. dx dt is 5/2. So I get 5/2 divided by 6 cosine squared theta. Well, how do I know cosine squared theta when I don't know what theta is in degrees? I don't need to. Cosine of theta is 6 on 10, adjacent on hypotenuse. So that is 3/5 squared, or I get 5/12 times 9/25. Do I want to be lazy? Yeah, I want to be lazy. Wouldn't have to do this, but 5 divided by 12 times 9 divided by 25. Could it be that easy? I think I'm just going to keep it 0.15. You can math fraction that if you want. So d theta dt equals 0.15. Now, what is that 0.15 unit rate? Here's the beauty of radians. It is just a flat-out radian measure. Radians per our time unit, seconds. So is it increasing? Is it decreasing? At what rate is theta changing? Well, it doesn't say at what rate is it decreasing, and it is definitely decreasing as the rope gets pulled in, the boat's getting closer. So theta is, I don't want to say decreasing, theta is changing, because they asked changing. at a rate of negative 0.15 radians per second at that moment. Okay. All right. So I think a little less going on in this, but that's kind of nice to have an introduction where we're talking about d theta dt. Okay, I think 3, pretty simple problem once we get the diagram drawn, but we got to reason through the diagram. We've had these men walking toward a light post shadow problems lots of times before, but not with rates necessarily. A man 6 feet tall walks at a rate of 5 feet per second toward a street light that is 16 feet above the ground. So he's walking along here toward it at a rate of 5 feet per second. At what rate is the length of the shadow? Okay, length of the shadow. So the shadow here, this is 16. Somewhere he's in here at 6, and here's his shadow. What rate is the length of his shadow changing when he is 10 feet? So at some point later, this length is 10. But we're interested in how fast is the shadow changing. So I think each of these are worthy of their own variable. I'm going to call this x. I'm going to call this s, which makes you a little bit nervous because I've changed s's to 5s before. But I think I'm going to use this for a diagram. At what rate is the length of the shadow changing? As I often say, talk calculus to me. Oh, what is ds dt? That's the question. When he is 10 feet from the base of the light. So that 10 could be a player. Let's see. Well, what do I want if I'm looking for ds dt? I want an equation that says s equals. To get an equation that says s equals, I want an equation with s in it. Well, careful here. S is to 6 as the common mistake here. There's a common mistake. See if you can think of it. I'm going to give you 5, 4, 3, 2, 1. The common mistake is to put x's to 16. But this is small triangle to small triangle equals big triangle. X plus s is to big triangle 16. So I get 6x plus 6s equals 16s. I'm going to group my s's. 6x equals 10s, or I get x equals 10/6 5/3 s, which might be useful, but as long as I'm doing it, only takes a second. S equals 3/5 x. Okay, so I now have an equation that starts with s. This is the one I want. So if I start with s equals 3/5 x, we haven't talked about the 10 yet, but I'm going to go ahead and I'm going to go ahead and find my ds dt. It equals 3/5 just dx dt. If only I knew dx dt. Well, dx dt, we're moving toward, this is dx dt right here. We're moving toward here at a rate of 5 feet per second. So that x is shrinking, so that is equals 3/5 times, if you like, -5, but that could be a false leader for us. We got to be careful we answer the question. So ds dt is just -3, and look at that, the 10 wasn't even a player. Okay, so let's see what we've got. At what rate is the length of the shadow changing? Changing. So if they said decreasing, we'd say at a rate of 3 feet per second. But shadow is changing at a rate of -3 feet per second. And there we got it. Okay, lots of different problems. The good news is they really fit in, you know, kind of like 3 to 4 little different kind of categories. They're all going to be, you're going to see a lot of similarities here. We got a pretty good cross-section of types of problems here. You were videotaping a race from a stand 132 feet from the track. It's my closest distance. Following a car that's moving at 264 feet per second. If I call this x and this r, they just gave me dx dt, x is getting smaller, is -264 feet per second. Okay, so we've got that. About how fast would camera angle theta be changing? They just told me, taught calculus to me. I am looking for d theta dt. Therefore, since I'm looking for d theta dt, I want an equation with theta in it. Now, typically, I would say I want an equation where it's theta equals. We'll talk about that one in a minute. But clearly, I want to talk about x. They didn't talk about r at all. However, maybe we're going to talk about this Pythagorean relationship. But perhaps I could just talk about, let's give this a try, and I'm writing in pen. Maybe I'm going to have to come back and get another sheet, but let's, or if you have a pencil, you might have to erase, but let's try this. How about just these values from theta, that's opposite adjacent. Tangent of theta equals x on 132. What am I going to get if I get the derivative of that? I'm going to get a d theta dt. Over here, I'm going to get a dx dt. I know dx dt. I think we're in business here. So the derivative of tangent of theta. I could take tangent inverse of both sides. Then I'd have to take the derivative of tangent inverse, and maybe I'm not comfortable with derivatives of inverse trig functions. So I'm going to take the derivative now. So I get secant squared of theta, d theta dt, let's not forget that, equals 1 on 132 dx dt, and I get d theta dt equals 1 on 132 times dx dt, negative 264, either divided by secant squared or times cosine squared of, boy, it'd be nice if I knew theta. Let's see. About how fast will your camera angle theta be changing when the car is right in front of you? When the car is right in front of me, theta, or right in front of you, theta has shrunk to 0. And what is the cosine of 0? The cosine of 0 is 1. So d theta dt equals, conveniently, negative 2 times 1. Now I have to answer the question. That's going to be a radian measure. About how fast is the angle theta changing? So changing, I want to include that negative because theta is getting smaller. So camera angle is changing at a rate of negative 2 radians per second we're dealing in. How nice. And then there's a second part to this. Well, I've got to be careful with that. Get tons of 2- and 3-part questions. How about a half second later? Well, a half second later, if we continue at 264 feet per second, we're out 132 feet. And now we look like this, theta, 132, 132. What's changed? Well, the only thing that's changed, the 132 is still the same. The only thing that's changed in this formula, the 132 is the same. The rate the car's moving is still the same. Maybe we could talk about, well, this is going to be a positive now because x is getting big, but it's getting big on the other side, and we always have to interpret the positive, negative based on the question later on anyway. But what's changed is the angle measure. The angle measure is now 45. You could make an argument it's negative 45. So I've got d theta dt equals negative 2 times cosine squared of 45. That's my negative 2. But instead of cosine squared, 0. So 45-degree reference angle, negative 2, the cosine is 1 on root 2 squared. I get negative 1 radian per second. Let's interpret the question. About how fast is your camera angle theta changing when the car is right in front of you, and a second later still changing. So theta is still changing if we consider it's moved into the negative. That would be an interesting one to talk about, but still, it's still going in the same direction. So we're going to say the camera angle is changing at a rate of negative 1 radians per second. I'm just going to put up here half a second later. Okay, so Hope that's helpful, but it's not going to be helpful for you if you think, oh, I've seen it now, I think I understand it, so I should be able to get through it. That is probably not going to be the case without a little bit of heartache along the way. You're going to have tons of practice on these. Obviously, you have some support here. There will be some homework videos. I probably won't do videos of every one of the homework problems. I'm just leery that you're not going to get in there and get your hands dirty, because it's like, oh, well, I tried one and it didn't work. Well, just for your information, this is now the 5th time I have done the problems in here. I've done them, and I'm going to do them 2 more times later today for the other classes, a couple of these problems. So you've got to get into them. You will get more comfortable each time you do it, but it's going to take work. We're not covering another section for until next, well, actually, this is the last, but we're not testing until the middle of next week. So for those of you that we're on a Monday right now, if this video is out there next year, then we're going to spend about a week on the remainder of these problems and another packet of example problems. Okay, best thing, treat it like a puzzle. My biggest advice is always do the talk calculus thing to me. When we say we're looking for ds dt, say, what do I want? I want an equation with s. All things created equal, I would rather have an equation that said s equals. So I had an equation with s. I don't think I want to do this until I can get s equals. It makes things a lot easier, with the exception of angles. If I can just get a trig function of it, if I'm looking for d theta dt, I just want a trig function of an angle. You want to go ahead and memorize all of the inverse trig functions, fine. We could turn this into theta equals tangent inverse of x on 132, but those bring a lot more difficult deriving into the means, and typically we're going to get, if we're going to get a d theta dt, we're going to have to be given a theta value somewhere to substitute in. So there you have it. Hope the hints helped. Hope we gained some wisdom, but you won't gain wisdom without practice, and you should get plenty of that. Good luck.